All right, LT5. Solve a linear system of equations that models a real-world context and interpret the meaning of the answer. Or should I say, Season 5, Episode 5. Title, not yet determined. Okay, so eventually we'll have a sweet intro song for our little mini series, our YouTube slash probably going to make it on Netflix and Hulu Plus mini series. Um, but you know it's still in the works. So once we have a title, then we can start working on our theme song. But until then, we're just kind of going middle ground here. Um, this first example is not actually on your notes. I want you to cross off the one that's on your notes. You don't have to write this in, but I want you to do the work for this example. Just do it in that space for your first example. I didn't like the first example that's on your notes, and so we are not doing it. So the example that we're doing now, and basically all of episode 5 here, Learning Target 5, is going to be a story problem that involves a system of equations, going through it and coming up with some equations first, solving it, and then determining what does that answer mean. What does your solution mean? So our example here is Edna leaves the trailhead at dawn to hike 12 miles towards the lake where her friend Maria is camping. At the same time, Maria starts her hike toward the trailhead. Edna is walking uphill, so she averages only 1.5 miles per hour, while Maria averages 2.5 miles per hour walking downhill. When and where will they meet? So, first thing I want to do is just make a picture of this so I can visualize. We've got the trailhead over here, and Edna starts at the trailhead. Here's Edna. She is hiking toward the lake, so we'll make a lake over here. That's an awesome lake. Those are waves. So she is headed towards this lake over here, and Maria has her tent set up here. And there's Maria. Edna is going to head this way. Maria is going to head that way. We want to know at what point somewhere in the middle here will they meet. Edna is walking up a hill, so she is going at a speed of 1.5 miles per hour. And Maria is heading downhill. She's going 2.5 miles per hour. The trailhead and the lake are 12 miles apart. So now that we've got a little bit of a visual, we can actually write a couple equations and solve this problem. Edna is going to start here. She is, if we make y our distance from the lake, the from the lake is important because we need a reference point. We can't just say distance walked. X is the number of, we'll say hours walked, since our speed is miles per hour. Hours walked. So we'll take our two variables and start to think about a couple equations for that. Let's look at Edna's first. Okay, Edna starts 12 miles away from the campsite, so her distance from the campsite is currently 12 miles, and each minute, or each hour, she gets, I should have said hour, each hour she gets 1.5 miles closer. So her distance from, or to the lake is decreasing by 1.5 miles per hour. Maria's, she is at the lake, so she is currently a distance of 0 from the lake, but she's getting further and further from the lake. So her equation is going to be 2.5x because she is moving away from the lake, and as time goes on, her distance from the lake is only going to increase, whereas Edna's is going to decrease. All right. So here is our system of equations. We can solve this really however you want. I'm going to suggest substitution. So we are going to take y equals 2.5x. We're going to take that 2.5x, sub it in there for y. This is stuff you already know how to do. So I am now just kind of reiterating a whole bunch of these steps you already know. We end up with x equals 3. I'm going to finish solving this and get y equals 2.5 times 3 is 7.5. Okay, so we can get rid of all of this. We have a solution of 3 comma 7.5. The last thing is to actually answer the question, when and where will they meet, we need to know what these two things mean. X, the x coordinate is 3. That means if we look at our definition for x down here, hours walked is 3. So they will meet after 3 hours at 7.5. That's the distance from the lake. They will meet at after 3 hours at 7.5 miles away from the lake. All right. These are the two parts. You need a solution and you need an interpretation of that solution to actually answer this question. Okay? Our second example, and this example lended itself really well to substitution. Our next example is going to work very well with elimination. So we have a school. Stefan goes to school and is selling tickets to a choral performance. On the first day of ticket sales, the school sold 3 senior tickets and 1 child ticket for a total of $38. The school took in $52 on the second day by selling 3 senior tickets and 2 child tickets. Find the price of a senior ticket and the price of a child ticket. So the first thing, and even before we do equations, I want to define variables. X and Y, you can do, actually let's not do X and Y. Sorry, Zach Johnson, I know that's going to make you mad. Let's do S and C. And the reason I chose S and C is because the two things that we want to know are the price of a senior citizen ticket and the price of a child ticket. So the two things we want to know are the prices of the two. All right. So we'll say S is the price of senior ticket. C is the price of child ticket. Okay, and kind of a clue for you if you're looking for what these variables are, just look at sort of what the problem is asking you to find. It's asking you to find the price of a senior ticket and the price of a child ticket. So there you go, there are your two variables. To set up an equation here, we have our 2 nights of the choral performance. We have night number 1 where they sold 3 senior tickets. So 3 tickets at whatever price this is. And they sold 1 child's ticket. So one ticket at whatever this price is. This right here, this 3S plus 1C, that gives you the total amount of money that they made, which that night was $38. So first of all, just to run over this one more time, we had 3 senior tickets at S price. We had 1 child ticket at C price, and that gave us $38 for that first night. The second night, we sold again 3 senior tickets plus 2 child tickets. C, again, stands for the price of the child ticket, not how many tickets. We already know how many tickets. That was 2. So C is the price of the ticket. That's what we want to find out. And that night they brought in $52. Okay. Now we're going to solve this using elimination. We're pretty close. We don't need to change these a whole lot. I'm just going to multiply this one by -1 and make this bottom one -3s plus -2c equals -52. And then finish solving. We get C equals 14 and S equals, if I go back to that top part, 3S plus 14 equals 38. We get S equals 8. So here's our solution here. C equals 14, S equals 8. The last part, we need to actually say what this means in terms of the problem. This means, and again, if we look back to what we were trying to find, C is the price of a child ticket. So a child ticket is going to be $14. A senior ticket is going to be $8. That's what the problem is asking us to find. And again, the interpretation part comes almost entirely straight from defining your variables. If you have defined your variables incorrectly, it's almost impossible to get the interpretation right. Okay? So you're before class. Jonathan is really hungry. He spends $45 on hamburgers and hot dogs. Hot dogs cost $3, hamburgers cost $4. Jonathan buys 12 food items. How many of each does he buy? This is the key, and this is the hint that I'm giving you. How many of each does he buy? That means how many hamburgers, how many hot dogs. And this is your clue for setting up your variables, setting up your equations, and then interpreting your solution. Finding the solution I'm not too worried about because we've spent a lot of time doing that, and I think you're good at it by now. So define your variables, set up your equations, solve it, tell me what your answer means. Next time on, we'll be looking at systems of inequalities in the Season 5B premiere. Tune in on Someday at Sometime Central.